think we're ready to begin. Thanks, everyone. First, I'd like to extend a warm welcome to everyone present, including speakers, moderators, and participants. Second, it is the custom of the Government of Canada to acknowledge the land on which we work and live. Since we are online today, a singular land acknowledgement doesn't capture our distribution across many locations. Because I'm located in Ottawa, I would like to acknowledge my presence on the traditional and unceded territory of the Algonquin-Anishinaabe people. And I invite you to consider your position on the land where you find yourselves. We do this to reaffirm our understanding of Indigenous peoples around the world. So thank you very much for that. Alan Young has been working hard to organize this event for us. So I'd like him to provide us with some of the details for today's session. Alan?
Hi, Rob. Thanks very much and welcome to all of you. We are going to be, well, I'm imagining most of you have spent a good deal of your past few months on Zoom calls, but I won't make any assumptions, so we'll just walk through a few of the technicalities so you have what you need to participate. First of all, there will be an opportunity to provide questions for panelists, and if you look at the bottom right-hand part of your screen, there is a Q&A box there. You click that. Those questions will go to our technical folks and moderators. They won't be seen publicly. However, if you do want to provide resources or commentary that is public and available to all participants, then use the chat function, which is a little bit to the left on the bottom of your screen. So those are two of the ways in which we want to interact. We'll also be providing a couple of polls throughout, so we look forward to your opinion on that. It's always great to get the sense of the experts who are coming in as participants, and it provides some really helpful insights, I think, to trends and approaches. And I want to note that we'll be recording this session, and then we'll be including in our final report both a link to the recording plus a link to those sorts of reports and resources that you may offer and want others to see. One other way that we are going to be providing an opportunity for input is through a whiteboard or Miro board. And for those of you able to and interested in providing more insights or commentaries throughout the session, maybe I'll ask Marion now to explain how you would access that, and feel free to use that at your leisure.
For sure, thanks, Alan. So I've now shared a link in the chat box, and so if you click on that, you're welcome to contribute to our collaborative whiteboard. This is using the platform Miro, and I hope that it's quite straightforward. You'll see that there are blank sticky notes on the left and right of the screen, and so feel free to click and drag those into a section of the whiteboard where you'd like to contribute resources, questions for the speakers, and we'll be returning to this at the end of the session. And if you have any questions about it, feel free to send me a direct message, Marianne Davies. Thank you.
Thanks. And with that, I believe we've covered off the technical side of things. We look forward to a great session and look forward to your input as participants, as well as our great host of panelists. And I'll hand it back to Rob.
Thanks, Alan. Thanks, Marion. I guess I forgot to introduce myself at the outset there. So my name is Rob Sinclair, and I'm with Natural Resources Canada. And I'm happy to be your host, but again, I'm just the face of the host, and there's so many people who help put this together. So let me just give a few intro remarks to get this rolling. So electric vehicles, batteries, complex supply chains, mining, critical minerals, manufacturing, the low carbon transition, the circular economy, commodity markets, a dynamic supply chain, multiple stakeholders. What's not to like? This is a great file to work on. So while we all know what a battery is, perhaps we are not all familiar with the term circular economy. Simply put, it's about maintaining the value of products, resources, and materials by keeping them in the economy for as long as possible, and of course, minimizing waste along the way. In effect, a circular economy decouples economic growth from environmental impacts. Key concepts are design, sustainability, resource efficiency, planning for the future. If you want to know more about the circular economy, there's a wealth of information online. You could start with the Circular Economy Leadership Coalition and the Smart Prosperity Institute. Watch for links in the chat space on that. There's many different sources of information. So to explore the subject of today, which is electric vehicle batteries, we have 4 segments. So the first one is an update on circular economy models for batteries around the world, which Alan Young will moderate. The second panel will be an update on current battery reuse and recycling supply chains in North America, with Maria Kelleher as moderator. Third, design and technology issues for optimizing the circular economy side of electric vehicle batteries, with Jeff McCarney moderating. And finally, a discussion of policy approaches in the 4th panel for supporting EV battery economies, which I will moderate. So the session objectives were provided in the outline, but to recap them just briefly, we're looking to contribute towards a circular economy battery supply chain vision for North America. We want to identify barriers and strategic priorities for achieving the vision. We want to explore roles, relationships, and responsibilities among key actors in rapidly evolving battery ecosystems. And finally, we want to identify next steps. So it's a little ambitious, but we're shooting for the stars here. So to help launch this event, I am pleased to introduce Jeff Labonte, who will provide opening remarks. Jeff is Assistant Deputy Minister of the Lands and Minerals sector at Natural Resources Canada. Over to you, Jeff. So your mic, you need to turn your mute off, Jeff, and then please proceed. Should be a button down in the lower left-hand corner for turning the mute button off. And I'm not sure if we're getting Jeff's, can you hear me, Jeff?
I'll try to fix this on the back end, and then maybe we can come back to Jeff in a few minutes.
Okay, all right. So I guess then what we'll do is move to the first panel, which is going to be moderated by Alan Young, as I mentioned. And perhaps when his mic comes on, then we'll bring him in to have his remarks. So sorry for the technical hitch here. Thanks very much. Alan, over to you.
Good. Thank you, Rob. We were just discussing this morning and probably cursing ourselves by noting how well all of the tech has gone thus far. I knew I should have been knocking on wood when I did that comment this morning. So yes, as noted, our first panel is going to be setting the context and setting the vision. There are lots of problems out there, but there's also some really interesting solutions and some great work that's been done. And we'll take a global level look with Matthew Senislas from the Global Battery Alliance. We'll then look into North American specific areas, our broader region, with John Kite at the Responsible Battery Coalition. And then Emma Jarrett, who has been working on a series related to EV batteries in Canada, will summarize some of the findings that they've had from their session and provide us some insight. So we'll sort of scope wide and then come down into the Canadian thing, understanding that this is overall going to look at the North American market as our broader conversation. But it's always important to keep the global context in that. But before we get going there, we're going to have our first poll. And just to test the waters on what you think now, I'll get Marion to set that up. We're asking, what do you believe is the most important obstacle to be addressed in advancing a circular economy for EV batteries in North America? And you'll see you've got 4 choices. They're always maddening to have to make a single choice, but we're going to ask you to do that. And while we fill that in, we'll give you a few minutes to fill that in, and then we'll see the results and then move directly to the panel after that. And Marion, you can let me know when we have sufficient registration on the vote to close the poll.
Sounds good. Looks like we're at about 60% of participation.
Great.
So I think I'll keep it open for 3 more seconds, and then I'll end the poll and share results.
Thank you.
Thanks, everyone.
Okay, well, we've got, as Rob said, complex problems requiring complex solutions, and pretty evenly split between the need for regulation, the alignment of standards for design and manufacture, the ability to collect and recycle the infrastructure and capacity, as well as the ongoing need for technical innovation. So this is what we anticipated to a degree in our 4 panels, as you will see, and hopefully we'll provide some insights on each of these areas and some inspirations as well. So with that, I would like to introduce Matthew Stanislas, who has been doing a great deal of work at the global level as Director of Public Policy and Engagement for the Global Battery Alliance. So Matty, you've got 5 to 7 minutes. Give us the big picture. And have we got the slides managed?
Yeah, I have the slides here, so Matthew, you can just tell me next slide, and I'm happy to move forward.
Okay, next slide. All right, so the Global Battery Alliance, real quickly, is a multi-stakeholder organization on the private sector side, everything from mining to minerals processing to cell, battery, automobile, and energy companies. On the public side, a number of governments, direct members. We also consult with other governments like the European Commission and the US. NRCan is a significant partner who's been helping us on multiple of our programs, most notably the Battery Passport. And we have a number of civil society organizations that focuses on some responsible sourcing and the others a scale up of electric mobility and renewable energy. Next slide. So real quickly, there's a report that we issued in 2019 in terms of the key elements to driving a sustainable battery value chain. And one of the most significant is establishing a circular battery value chain as a major driver towards the Paris Agreement. Next slide. So this is a snapshot of the vision statement. We want to drive a 50% emission reduction in the battery value chain. That is the manufacturing of a battery. Coupled to that is to drive a 30% emission reduction of the transportation and power sector towards the Paris goals, and doing so in a way that aligns with economic value creation, particularly at a local level, to have local benefits from the scale up of the battery value chain, and doing so in a way that safeguards human rights and economic development. A key issue we're working on right now is the issue of child labor in the cobalt value chain, to eradicate that. We also are working on addressing energy access with current focus on Africa and India. Next slide. So this is, is a quick snapshot of the opportunities that we see to drive a circular battery value chain. And based on our report, we believe that realization of circularity can drive close to a 20+% reduction in the cost of batteries. which we believe can drive up to a 35% increase in demand through the reduction of cost of batteries. So what I've highlighted in yellow are kind of the near-term opportunities that we see, improving the lifetime of a batteries, both in first use and in adapted second use, as well as increasing the product quality, high quality recycling of batteries to be reintegrated into new batteries. Next slide. So what this shows is the analytics and modeling as to how circular levers can not only return a positive economic rate of return, but things like repair, refurbishment, repurposing, shared mobility, and V2G, but also shows the positive greenhouse gas reduction from these circular levers. Next slide. So again, I was referencing this earlier. So optimizing these circular levers, we project can address, can result in a 17+% of reduction in the battery cost, which is directly tied to reducing the cost of batteries and therefore increasing the EV market share. Next slide. So to give you a sense of the how, the European Union has adopted digital product passports as a primary mechanism to drive circularity, as well as a number of other key outcomes like greenhouse gas and data benchmarks, due diligence, and pointed to an effort that I'll get into in a moment, the Global Battery Alliance's battery passport, as a way of driving these outcomes. Next slide. So quickly, what we believe that and we're trying to build is data to drive a transparent value chain and global solution for securely sharing and authenticating information to confirm claims of carbon, of responsible sourcing, and key data to drive recycling. In our consultation with repurposers, they point to key battery management system data like battery health as critical to be able to adapt an EV battery for energy storage purposes. When we talk to recyclers, they point to the availability of battery chemistry as critical to scale up recycling, potentially reducing the cost of recycling, the back-end cost of segregation and testing by 25%. Next slide.
Looks like we may have a connectivity problem there. We'll give him a few seconds more, and then if that persists, we'll move on to our next panelist.
I think the problem may be not our hand, Donald.
Can you hear me, Alan?
Yes, I can now. Sorry.
Oh, sorry about that. I got knocked out. To really bring data to drive things like provenance of materials, drive things like circularity. Next slide. One of the things we're working on, and we're having an event at the Climate COP, the climate conference, to establish a data governance rules to drive some of the outcomes that we're talking about, bringing together governments, key companies, and civil society to look at establishing a framework, a global framework of enabling access to certain data, or protecting other data, but ultimately develop confidence in data to drive circularity and greenhouse gas authentication. Next slide.
And we should probably wrap this up fairly soon, so we've got time
Okay.
for.
Yeah.
Thank
So
you.
I will stop here with this slide in terms of what we really need to do is shifting from a waste management hierarchy to a circularity hierarchy, and really grounded in life cycle based analytical frameworks, traceability and data analytics as a way to kind of make decisions and use data to drive circularity, recycling, repurposing. And prioritize certain activities like design, remanufacturing, repurposing. So I guess I will stop there. Thank you.
Thank you, Matthew. That's we could spend the entire day just working through some of that work, and interesting the focus, that primary focus on the foundation of data. I'm going to come back after we hear from our other two speakers. I'm going to come back with a couple of questions if we have time. So, John, I'm going to pass the microphone over to you.
Great. Thank you, Alan. Appreciate it. And thank you, Matthew. That was very interesting. I'm with RBC, obviously the Responsible Battery Coalition. I'm the Director of Communications and Programs. We have particularly North American focus, although we're also focused internationally as well. But we think it's abundantly clear that establishing a circular economy for next generation EV batteries is essential to both the environment and, in our opinion, to national security. And that becomes a resource issue. We think the solution to this is two-pronged, and I think this builds from what Matthew was just talking about. There needs to be a strong, innovative market element, and there needs to be a sound, rational, and practical public policy element. And we need both in order to have a long-term sustainable approach. On the market side, we believe that the preferred solution is for the market and the manufacturers to drive the circular economy, to take the lead by using methods that reduce emissions while also creating stability across the markets. The key to that, in our opinion, is to use an approach that considers the entire life cycle, regardless of where a company might be in that life cycle. Entities in the supply chain can't really just look at their piece of the chain, but rather they need to be looking at how they fit into the overall life cycle of the battery. I think we have to recognize that when we're considering emissions related to the entire life cycle, we can and should be looking at trade-offs within that life cycle and where should we be focused. For example, one approach to producing a battery may have a higher emissions profile at the front end, but the battery itself over its entire life cycle may have durability, performance, and charging advantages and be highly recyclable. And those attributes that become apparent over the life cycle and at the end of life could actually more than offset the higher emissions profile at the front end. So this approach led us to a joint cooperative project with the University of Michigan to develop what we have called the Green Principles for Mobile Battery Application. And we can make the abstract and the full principles available to anybody after this session. But it's a holistic approach that uses 10 principles to optimize practices during the battery's life cycle to reduce greenhouse gas emissions associated with the battery from initial material extraction all the way through end of life. It includes considering the battery's materials, where they came from, how the battery was manufactured, the weight of the vehicle, how the battery is charged and discharged. Again, full life cycle analysis. And once each of these critical factors is characterized from an emissions perspective, then we can look at the full life cycle and pinpoint where greenhouse gas savings can occur. So that's on the market side, and we hope that these principles will over time be widely adopted. On the public policy side, we think that much like the circular economy for the lead acid battery, building a circular economy for the next generation of advanced batteries is going to benefit from supportive public policies. I know we all may have a little trepidation when we talk about standards and regulations, but good public policy can be very beneficial. And I think an example of this is battery recycling technology has advanced to the point where we can now produce new cathodes from recycled material from old batteries. But the costs involved in doing this are prohibitive. A new recycled cathode may be up to 3 times as expensive or 3 times higher than the price of one made with newly extracted materials. So that's really a disincentive for battery and specifically cathode recycling. And that in turn creates or continues a dependency on unstable, undesirable, or foreign sources for raw materials and greater emissions associated with the life cycle. So we believe that there's a strong and important role for public policy to incentivize the use of recycled materials in the next generation of batteries. We think the focus of that public policy should be on the use of critical materials in construction of the battery, particularly the cathode and the anode. And I don't want to steal anybody's thunder, but I think a good example of public policy support involvement in this is the resale project that Jeff Spangenberger manages in cooperation with the Department of Energy. And perhaps Jeff may touch on that a little bit later. And I think it would be also interesting to hear from Kunal Palfer from Lifecycle about the issue of cathode recycling and where they are on that. We view those as really critically important areas for advancement and areas in which public policy can help incentivize and spur further growth. So in conclusion, clearly a circular economy is imperative to the future of EV batteries. We're looking at literally billions of advanced batteries that are going to be in need of management and recycling beginning as soon as yesterday and certainly expanding significantly out through the next couple of decades. And without a full, true circular economy approach to this, we will all continue to be vulnerable to geopolitical and market forces that are beyond our control. So I think we have an opportunity to be the leaders and to seize the reins here, but it involves a lot of cooperation and a lot of thought. And again, that innovative market-driven approach complemented by smart public policy. And I'll stop there. Thank you.
Thank you very much, John. That's super helpful and very encouraging in terms of the very holistic approach along supply chains and between public and private sector. We'll come back to that, I think, in some questions for follow-up. And Emma, I'd like to turn it over to you to give us your insights into how conversations with the Canadian sector have shown interest or obstacles around circular economy futures.
Absolutely, thank you. So as you mentioned, Alan, earlier, Electric Autonomy Canada hosted a 6-part series looking at the Canadian EV battery supply chain. And our questions were pretty simple. It was, do we have the ingredients to do this? If so, what needs to happen to execute the plan? And the third being, what do we stand to lose if we don't get our act together on this? And we covered the supply chain across the spectrum, so starting at R&D and going all the way to recycling. And what became really clear from session 1, I think it was like one of the first questions we got, was someone from the Canadian public saying, well, what about recycling? And what about recycling became like this theme through all the panels, where everyone wanted to know, how is this new economy that's coming up going to be actually, clean and less waste and better than what we have now. And that was, for me personally, very encouraging to see that this is a top of mind issue for the public, because we know that, the public consumers drive what businesses will do. So I think there's a real appetite just on a social conscious level for Canadians to want to know how our system is going to be created to accommodate for circularity. But there are challenges, and we heard that from our panelists who spanned coast to coast to coast across Canada, and they're on the front lines of their various industries. And the challenges broke down into 2 categories, prefaced by a big win, which is we have everything we need here to do this. We just need to get everyone pointing and moving in the same direction. So the first challenge is that all of the facets of the supply chain in Canada are still quite siloed. So you have labs working in R&D that aren't necessarily talking to the OEMs unless the OEM is sponsoring the lab about what they need out of their battery cells. And maybe they aren't talking to recyclers, and they're maybe not talking to miners. So you have everyone kind of doing their own thing, but not coordinating as effectively as they could be. And that's in part because they have different goals. On the R&D side, I mean, you don't want a cell that is so recycle friendly that it falls apart mid-commute when someone's driving. So they're building their, a battery cell to last for as long as it possibly can be, as held together as tightly as it can be. Whereas on the recycle end, the other end of the supply chain, you have, companies like Canal from Li-Cycle who are like trying to undo the battery and hoping that there's a way to create battery cells in the future that are more recycle friendly. So it's less labor intensive, less costly. And, then it's the debate of, do you do Second Life to do a different spin on the circular economy, or do you do straight to recycle? And the opinions are varied there. I mean, recyclers they're biased, of course they are. They may say, head straight to recycle, don't pass go. That's where we need to be. And utilities, their interest in batteries, like on Hydro-Quebec, they're interested in Second Life, grid storage support. So it's, you do have people pointing in different directions there. So the gaps that emerged were not insurmountable. In terms of our supply chain, we needed, by lots of different accounts, some sort of mandate, either at the government level or at an organizational level, like the European Battery Alliance, that's corralling everybody and getting that momentum heading in the right direction. And happily, at the beginning of the summer, we didn't have that, and now we have both. We have had a really concrete government pledge to get 100% light duty new vehicle sales by 2035. And we have also had a new organization form called Accelerate ZEV. And it's our version of a supply chain alliance. And then the other gap we had that remains still a big problem is we don't actually have any meaningful cell manufacturers in Canada right now at a scale that's large enough to be impactful on the supply chain. So yesterday, a company announced that they're in very advanced talks, by the sounds of it, to bring a battery cell manufacturing plant to Quebec. And, they're not the one answer. They said themselves they need more of their colleagues and counterparts to join in and bring other plants, but it's the first pebble of the avalanche, essentially. And so I'm pleased that compared to what we had 4 months ago, we're now in this position where we've filled two of our three, not filled them, but we're on the way to filling two of our three major gaps. And then the third gap that's outstanding is the anode cathode capability. And we're still in a position as a country where we don't have a concrete answer to how we're going to solve this problem. And we will still need, at this stage, to be sending our raw materials out into other countries for refining and turning into anode cathode materials to go into battery cells. But there are hopeful indicators that will be changing soon. And in the coming months, I think we can expect, based on the pace that everything else is running at, that we will have developments on that end too.
Thank you very much, Emma. And it is remarkable, as we said at the outset, just how fast this is coming and generally trending in the right direction, which is not to underestimate the complexity and the size of the task, but we're seeing some real momentum across a number of fields, and you raised some really interesting questions around capacity as well as the alignment of signals from market and government. We have about 15 minutes left in this panel, I believe. And so I wanted to come back to our panelists. I don't see any questions currently in the Q&A box, so I have some prepared myself. If anybody from the audience would like to have a question posed, please put it in the Q&A box. So Matthew, you've got an ambitious global agenda and vision, and you've got quite a bit of alignment from a diverse sets of public and private sector actors. But of course, the difference in terms of regional responsibilities, regional impacts are quite profound. And it sounds as though you have a role in mind for different regions to play to contribute to the broader advancement, whether it's technology, capacity, markets, or others. Any reflections you could offer to the unique role that North America can play on this global vision? Of course, it's important for us to get our act together and manage the tsunami of production that will be coming upon us. But do you see any particularly unique roles that North America can play in this global vision?
Well, absolutely. I mean, North America is very much a global center of automotive manufacturing, and I think leveraging that expertise, historic expertise, but also some of the efforts in Canada in terms of aspects of the battery value chain, efforts in the Biden administration to scale up the battery value chain. So I think North America, the ecosystem North America, can really help advance a global solution. So I know in talking to the Canadian government, the Biden administration, what they're really looking to do is to establish a level playing field globally, where there's fair competition to scale up the battery value chain. So I think there's a private sector side of it in terms of experimentation, in terms of bringing their knowledge and technology. There's also a policy alignment that I think that both the Canadian and the U.S. government can really help foster the climate for scaling up the battery value chain.
Great, thank you. I'll turn to John, and you touched on several really interesting points and a lot of the complexity that you're trying to manage through a deeper, thoughtful question about which problems are we really solving for here, because it's easy to get caught in lots of rabbit holes if you wanted to solve narrowly for a particular problem at a particular space, but we have to think of whole systems. The other thing that struck me was a closing comment you said about the need for collaboration and the need for working together to get these common understandings around life cycle priorities. And I was wondering if you could elaborate a little bit on these areas for collaboration. It's a theme that comes up a lot in other circular economy discussions we've had in the metal sector. And do you see areas where it's currently absent and that you would focus effort to bring and convene people together on? I hope that's not too broad a question, but
oh no, that's an easy one.
Yeah.
No, I wish, Alan, that I could point to 2 or 3 specific areas where there's a problem that can be easily remedied. I think we're too early in the evolution of the advanced battery-driven ecosystem that is, I think, the future, to be able to have those clear areas where X, Y, or Z could solve the issue. That actually, I think, illustrates the importance, frankly, of forums like this, of the work that the Global Battery Alliance is doing, of the work that is being done at Argonne. Let me put it this way. the sooner we can begin to identify areas of commonality, I think we will then have a greater opportunity for solutions to emerge. But we've got to get after it quickly, because the production, I just said, Tesla sold 250,000 cars last month. That's another 250,000 batteries. That's just one little company, not little, but it's one company. The need for collaboration, the need for cooperation, I would argue selfishly, the need for adoption of our green principles for mobile battery applications is on us now. Again, forums like this, I think, are very important, where people who have a broad range of interests, both economic and policy, can get together and start to talk about these things. I think resource availability is going to be a critical issue, and that's why recycling is critically important. But I think we've got to continue to look for areas where we can collaborate. And one of the challenges in there is it's a highly competitive business environment. So there may be business incentives not to collaborate, not to cooperate. But I think we've got to look beyond that and look at the bigger global picture, both from a resource allocation perspective or the availability of resources and the environmental impacts. But the time to be coming together and trying to frame out those actions is now.
Yeah, I think that's I mean, the importance of the pre-competitive space is really in and of itself highlighted in a number of areas that we've been looking at, and it often doesn't exist. There are some examples, but if that becomes a deliberate part of a strategy to nurture, in the context of the fact that we should all be doing things in a more sort of transparent and collective way, I think those two sort of organizing principles are going to be really important to move the acceleration where it needs to go. We've just got a few minutes left. I had some questions for Emma, but I'm going to go to the panel Q&A and open that up, and I'll give Emma the first chance at answering those. Bill Westcott has asked, what's the role of EPR for EV batteries? Who is leading with service models and versus ownership models as part of this? So Emma, did you touch on, I know Canada has a pretty interesting but very diverse EPR policy. Do you want to talk about EPR in the Canadian context?
Sure. Full disclosure, never heard the acronym EPR before, so I can just spell that one out for me.
Oh, I'm sorry, extended producer responsibility. So the recycling systems, and if you don't want to answer this one, we can punt it to somebody else, but just, you know, we've got the typical battery recycling systems and the curbside collections, and obviously those don't apply. Is there something unique that was talking about for the EV sector that came up in your discussions?
Well, I mean, one of the areas that the recyclers were united on was this need for a spoke and hub kind of approach, where maybe this is a recycle reuse problem we tackle regionally, which would mean setting up recycle centers across different areas of the continent. And I say continent deliberately because they say it may make more sense to divide this up north-south rather than east-west. Mm-hmm. So you have these recycle centers that service you know, slices of the continent, so that, you know, you aren't having to truck spent batteries thousands of miles to get to the nearest center. It's more integrated that way, and then that feedstock, for lack of a better word, of those recycled minerals and parts can then be just sent right back into the local area that they came from. So that I felt was a bit of a unique spin. And in terms of, you know, curbside collection for your used EV battery, nope. Like the public isn't going to be ripping the battery out and putting it, you know, at the end of their driveway and calling a special number. But I really did think it was interesting that when GM announced their new Ultium platform, every one of their battery packs has a website code, like a URL for a recycle program. So, you know, it's good that OEMs are thinking of creative ways to remind people, you know, this is something you have a role and responsibility in too. Don't just send your car to a landfill. Make sure that you contribute as well to our circular economy. And I think that's just a theme that keeps coming up. Like we all have a role to play in this, and it just doesn't work if one slice of the pie decides not to participate.
Right. Yeah. Thank you. Yes, go ahead, Matthew.
Yeah, I mean, I would reinforce a comment made on the chat is that I don't think that we should approach the recovery of EV batteries in a one-size-fits-all model. I don't think the traditional EPR model fits batteries for EV. I mean, the batteries are much larger. The expertise necessary is very specialized. So rather than jump to a model, which frankly, from my perspective, is highly inefficient, I think we should look at what works best to recover and repair and refurbish EV batteries. So this includes things like potentially disassembly standards, things like traceability of batteries. We're working with GS1, and create there's also experimentation of the servicing model where various parts of the globe are looking at not actually having the battery sold, but having retained ownership retained, so it goes back to the original manufacturer. So I would strongly argue against the application of EP model because we just need to fit and tailor it for what works best for the EV mobility sector.
Great. Well, I hope, Bill, you've that answered some of your questions. If you want briefly, John, go ahead, and then I have one last sort of commentary from the chat.
Thank you, Alan. I was just going to build on what Matthew was saying. There's also the whole issue of secondary use. These are batteries that have huge potential for secondary use, and the issue of ownership, transport, liability, insurance issues, all of those issues also need to be addressed. And I think they're a little bit on the back burner because of where we are in the world of advanced battery production and use. But if we don't take a look at those issues as well, we will not get the greatest efficiency and the greatest use out of the batteries. And that will be a problem, both premature recycling, but also in a circular economy perspective, not maximizing the use and the value that's inherent in those batteries. So it's a whole nother set of issues that need to be addressed as well.
Great. Yeah, that certainly has come up in the interviews and the research we've been doing, and getting alignment on that one, given the range of interests and issues, including safety, is a meaty discussion, shall we say. I think we'll wrap it to a close there, although I will just reflect Lindsay Redekop's commentary, which sort of builds on this comment that we really need to think circular, not recycling, and think whole systems. So that starts at the mine site, and circularity begins there, not only for the miners as producers of materials, but also as major users of industrial materials. So we're looking at circularity right from the extraction stage through to the production, the design, the production, and as you say, for the extension of the life. So it's a really fascinating model, given the durability, given the urgency on demand and the expansion of markets, to be working on this. It seems to underscore what I think all of you are saying is this is an urgent area that is full of opportunity and necessity. So with that, thank you very much to the panelists. You've set us off on the right track. We'll be diving more deeply into a number of these issues with subsequent panels, and I'll pass it back to Rob to hopefully have Jeff online and have our opening comments.
Fantastic. Thanks, everybody. Thanks, Alan. That was really great. Great start. So I'm going to turn it over to Jeff Labonte again, Assistant Deputy Minister. Had a little bit of technical issues, but I think he's smiling, so that must be a good sign. Jeff, over to you.
Thank you very much, and my sincere apologies for the technology belly flop that happened earlier. Maybe I have an electronic device that can make its way to the recycled economy sooner than later. Thanks very much, everyone, for the opportunity, and thanks, Rob and Alan, for the conversation. The benefit of me speaking now is that I had a chance to listen in and hear the panels, the first panel's discussion, and I think it just reinforces a number of really important things that I'd like to share with you just about and welcoming everyone. So first, thanks everyone for taking the time to participate in the discussions. As you can tell through the first panel, there's a lot of passion, there's a lot of really good, interesting issues, and it's really a blending together of the environment, the economy, lower emissions, a much cleaner and greener world, and a world in which we think more broadly about the systems that feed the everyday lives we have, and the mobility and using vehicles being an important part. It goes without saying, really, that Natural Resources Canada and the Government of Canada are squarely focused on the priority around emissions reductions, around the clean economy, and around critical minerals. And one of the things I'll talk a little bit about is just ensuring that the supply of critical minerals meets the rising demand. And look no further than the topic of conversation today in the panel on electric vehicles. And really what's of deep interest is that the scale of the transformation of the sector, the transportation sector and the mobility sector, is disruptive. And that really bears a conversation that this panel and set of panels is talking about, but even more broadly, the circular economy and how we think about it. And when we think about the scale of transformation that will happen over the next couple of decades, and how that will reestablish the way that we build, develop, use, and then reuse and return and think about supply chains to meet these particular challenges. We know that critical minerals are a key for the transition to a low carbon and digitized economy. We also know that a low carbon and digitized economy needs different materials in different proportions and amounts, and that the applications that are driven in that economy, whether they're permanent magnets, batteries, solar panels, or wind turbines, use new things. They're also required for inputs of other advanced materials and supply chains, including defense and security, consumer electronics, agriculture, medical applications, and as we learned through the pandemic, PPE and other things important in the infrastructure of our economies and our societies. Earlier this year, through extensive consultation and work, Canada released its first critical minerals list. It has a list of 31 minerals that are considered critical for Canada, and more importantly, critical for its partners, including the United States, the European Union, Japan, and other countries such as Australia and South Korea. The focus of our effort was to bring attention to those areas where Canada could and does have an important source of critical minerals, and it helps us inform where we would want to go with our international partners, such as under the Joint Action Plan on Critical Minerals collaboration with the United States, the Strategic Partnership on Raw Materials with the European Union, and other like-minded conversations, as I mentioned, with other countries. So we are looking at critical minerals and how they supply chains and how they contribute to the importance of our low carbon economy aspirations and directions across the world. And we're looking at it through the lens of what can Canada do and what does it bring to the table and how do we contribute, but also draw from others what is the right approach and path forward. So conversations like today really help further bring attention and draw focus to where there are gaps, where there's opportunities, as the first panels pointed out, and where there's like-minded intentions. So here in Canada, we are developing a critical minerals projects inventory to help map out where the potential supply might come from new mines and investment opportunities that will drive the development of new supply. The goal is to have the materials that Canada needs and its partners can draw from as they meet manufacturing security and economic interests. The vision on critical minerals aligns very closely with our our collaborative vision we share with our provincial and territorial colleagues in Canada related to the mining sector, which is articulated in a national plan or a pan-Canadian plan called the Canadian Minerals and Metals Plan, or the CMMP. This supports competitiveness of the mining sector, but also looks at minerals and metals from a whole new vantage point, bringing focus to how mines produce materials, how exploration takes place, those that participate in the process, and including the footprint and reducing the footprint from the production of materials, and to ramp up and include a circular economy approach to principles and practices. So looking at the whole process, as was pointed out already, in a different way. For example, there are a really important focus on what would be termed mining value from waste, an initiative that looks to improve the recovery of more materials at the production and mine sites, as well as drawing from existing materials, including the recycling and circular economy, better and longer and return of those materials to the economy for reuse and for repurposing. So that conversation is well underway, and really look forward to ensuring that the panels that follow will continue to flesh that out and share their experiences and benefit to us. We are looking at a whole range of different issues, so we are really pleased by the opportunity to further interest and share with the World Circular Economy Forum. That's why we're proud to sponsor and help support the event and have supported the work. There's another one forum coming up on the 13th looking at end-life electronics. So today we do have the benefit of a North American and international audience. The experts here will bring a range of perspectives and expertise to represent many views, many vantage points, and many perspectives that will help us as policymakers in government, but also as deeply interested in the circular economy approach to things, how to address EV batteries from the discovery to the processing, manufacturing, recycling, and reusing at the end of their quote unquote first life. So as the themes have really pointed out, it is fitting, collaboration is important. We know that Canada is a part of a broader economy, a part of a global world, and that is important that we work with our partners to tackle the challenges, growing the R&D side of a number of the opportunities, as well as looking at the regulatory and policy frameworks to ensure alignment and to have as seamless as possible an economy and an integration across North America and to with other partners around the world. As we grow and look to the future, EV sales in Canada are about 55,000 units a year and growing, rising from negligible numbers to about 3 to 4% today. And we know that that's going to ramp up exponentially. So what we know is that the demand and the need for building a circular economy around EV batteries will amplify significantly between now and 2035, when Canada expects that all vehicles will be zero-emission vehicle sales. So our colleagues around the world have similar ambitions. They have similar policy frames and similar challenges in front of them. So in this context, I look forward to the conversation. I want to underline the importance of the dialogue and to really thank those who are participating today and have taken the time to join the conversation, and those that are listening in to kind of draw from and to contribute to the chat and the dialogue about where to go. So thank you very much for the opportunity, and my apologies again for the technology snafus. But as far as we're concerned, we'd really appreciate the panel and the conversation going forward. Merci beaucoup.
Thanks very much, Jeff. That's a really good recovery. And you certainly highlighted how complex and how challenging the area of electric vehicle batteries are. So now what we're going to do is turn to our second panel, which will be moderated by Maria Kelleher. And this is on the reuse and recycling supply chain. So I'll turn it over to Maria so she can move it on from there. Thanks.
Thank you, Rob, and welcome everybody. We've got a great panel of experts here today to talk about the current state of reuse and recycling the supply chains for electric vehicle batteries in North America. The format will be that we will introduce ourselves briefly, and then I'll ask a series of questions to the panelists. And we will provide links to various reports that we mention as we go. So my name is Maria Kelleher. I have a company in Toronto, Kelleher Environmental. I have a master's in environmental engineering, and my company focuses on circular economy, climate change, producer responsibility, and recycling. I've done a number of reports on lithium-ion batteries in particular, one recently for Natural Resources Canada, focusing on the full battery supply chain within Canada, and another for the American Petroleum Institute, on recycling and reuse of electric vehicle batteries, and a link to that report will be put on the chat. Jeff, can you introduce yourself?
For sure. Thank you, Maria. So it's Jeff Haltrecht. I'm with Call to Recycle. Been involved with the company since 2012. We are a not-for-profit. We operate the largest battery collection and recycling network in North America. Toronto is the Canadian head office. Atlanta is the United States head office. Combined 194 million pounds of batteries is what we've orchestrated coming out of market since 1994. We handle end-of-life batteries, damaged, defective, recalled batteries. Clients, about 400 clients, and we span the household battery, power tools, laptops, cell phone, and now into the e-bike, e-scooter, and electric vehicle, and other e-transport industries. Thanks, Maria.
Thank you, Jeff. And Kunal, can you introduce yourself?
Yeah, Kunal Falfer here, Chief Commercial Officer of Li-Cycle, which thanks to the panel before has been mentioned a couple times. We're a lithium-ion battery recycling company and are currently rolling out our what we call our spoke and hub technology, one piece being mechanical processing and one piece being the hydromet processing, with 2 facilities operational and 3 under construction at various stages of development here in North America, and looking beyond our borders to expand our business internationally.
Thank you, Kunal. And Taylor, can you introduce yourself?
Yeah, thanks, Maria. I'm a regulatory and policy analyst at the U.S. Department of Energy's National Renewable Energy Laboratory. NREL is a government-owned, nonprofit operated research institute that was established in the 70s. I'm an attorney by trade and lead a group of legal analysts at the lab, and a lot of the work that we do focuses on analyzing how policy and regulation impact new technology development and deployment, as well as kind of policy solutions and frameworks to overcome and identified technical market and other barriers to a circular economy for energy materials.
Thank you, Taylor. So I'll send the first question to Jeff. Could you tell us a little bit about the project you're currently involved in with Call to Recycle, and some challenges and lessons learned?
Yeah, for sure. You know, it goes back to 2018. We were having a conversation, the board and management. We had 2 questions. Where are the electric vehicle batteries, and how are they going to come out of market? And it's 2 simple questions, but for all those of us who work in the industry, you understand a bit of the complexity of the logistics of moving these batteries around. As we looked at this, divided it into 2 areas, electric bicycles and electric vehicles, because of the volume of those 2, and can share that we are fully operational at this point, collecting electric bicycle batteries in North America. Canada first, the United States is just starting. I'll continue down the path of talking about electric vehicles at this point, because I think that's the one that's more pertinent right here. Under warranty, the majority of batteries are at the dealerships. Out of warranty, they're at auto recyclers. The channels that we're finding these batteries come out of, generally speaking, 5 channels. Battery factory has offputs that go straight to a recycler. The dealerships have batteries that might go to remanufacturer or to a recycler. The remanufacturer itself has batteries that come out of there. Auto recyclers, very fascinating. I love this industry and learning more about it as I work with the Canadian auto recyclers and the American auto recyclers. And then independent garages, very few of them, but a few do have some batteries at this point. What I could share with the group, and we're fully operational here in this space, so this is real-time data, 60% of the cost of handling a battery at end of life is all on the logistics side, freight in particular component to that. An auto recycler could have between 5 and 10 EV batteries per yard. I've seen as high as 50 hybrid and full electric batteries in a given recycler's yard. Today, 80% nickel metal hydride, 20% lithium is what's available, but that's just based upon the technologies available and going back with the Prius starting off with nickel metal hydride. So there's a number of them available. Today it costs to recycle, but tomorrow we'll see. It might get more to a neutral area, but what will not change is the cost of freight, which then leads to the question is how many times are you going to touch it? Every time you move a battery, it costs about $200, $250 to move it. So you really have to have a smart logistics network that is highly, highly cost effective and is very smart in how many times you're touching and where you're moving the battery. And the challenge that you mentioned, it's really just piecing this together. I love the first panel, a lot of ifs about, what about this, what about that? We're living it, it's real. And I can tell you, no batteries are going to landfills. We know where they are, we could see them. You just have to start going to get them and start moving them to the right place, whether it's repurposing or recycling. And maybe to wrap this piece here, good news, there's enough capacity today. There really, really is, with what Li-Cycle is doing, and Kunal's going to talk next. And then you have Redwood and Battery Resourcers, and I can name a number of them that we work with. There is more than enough capacity today, and there is more than enough capital being made available for the expansion of these facilities to handle the future of demand.
Thank you, Jeff. I think I'll move straight to Kunal now and ask Kunal to describe a little bit for the audience what Li-Cycle does, what facilities are in place now, and what kinds of materials you are processing now, leading up to what chemistries are you seeing now, and how do you think that will change over time? And if we have time, we'll come back to that question.
Yeah, thanks, Maria. So I guess in my intro, I briefly described it, but I think in the last panel was also mentioned, and it ties into Jeff's point. One of the major challenges is logistics. And what we're trying to do is implement what we call our spoke and hub concept, or it's not even a concept now, it's a reality, by putting the front end processing or mechanical process, which we call our spoke, close to population centers, close to manufacturing sites, and closer to where the batteries will come from, to help reduce, to the extent we can, that logistics cost. So we have our first one that was built in Kingston, Ontario in Canada. Then we built one in Rochester, New York, and now we're building 2 sites or spokes in Phoenix, Arizona, and Tuscaloosa, Alabama, which will A, get us closer to California, but B, put us in the neighborhood of a lot of auto manufacturing in the Southeast. And in general, in the Southeast, there's a gap in processing capacity. But that's just the first phase of our process to bring batteries to intermediate material. And then we're going to move that intermediate material to our hub. So we've piloted this technology to recover battery grade materials, and now we're building a large scale hub in Rochester, New York. We often get the question, why Rochester? We're leveraging the infrastructure from the Eastman Business Park there, former Kodak, or still Kodak, actually, sorry, where there's a lot of utilities infrastructure that you can benefit from in such a chemical operation. Mm-hmm. And then part B there, Maria, what we're seeing, I would say, I've been working with the company almost since inception in 2017. And we've probably in the last 6, 8, 10 months, also depending on customer base, but we've seen a gradual shift versus say 3 years ago when we were doing a lot of consumer electronic batteries. Now you're already seeing, because there've been some EVs on the road, you're seeing some EVs come back with problems or hybrids. And we're also seeing now, as manufacturing's ramping up, manufacturing scrap from cell through to pack production from the various OEMs. So our mix of material related to the chemistry has shifted to a nickel heavier chemistry. We've actually even adapted our hub design in the process, as we've seen that compared to when we piloted the technology to now, we're seeing a lot more nickel in the market. And that's what everyone's been talking about, higher nickel material in EVs and transportation applications. I would say in the last 6 months, you don't see it in the market from a recycling perspective yet, but there's been this resurgence of talk in the Western world of LFP batteries. Mm-hmm. And I would say 2 core segments there are commercial transport, looking at more LFP. It's already common, Maria, as we spoke about in places like China. Mm-hmm. But even here, we're starting to see that a little bit more in new vehicles. And then in energy storage, I think there's been a transition for new projects going in to really focus on LFP, whereas the ones we get out of the market already that were installed 5 years ago are probably NMC. But we're going to continue to see the flavors evolve over time. Yeah.
Thank you, Kunal. So the LFP, for those who are not familiar, is lithium ferrous phosphate batteries rather than NMC, which would be nickel manganese cobalt is the MNM. Okay. Great, thank you. So Taylor, you did a great study for the NREL, or you were involved in a great study for the NREL, and I was wondering on the circular economy and EV batteries. So you've hit the nail on the head there in terms of what we're talking about today. I was wondering, could you comment just to start with, from the recycling point of view, some of the challenges in finding circular economy solutions to end-of-life electric vehicle batteries? And we'll come back to reconditioning and reuse later if we have time.
Yeah, of course, Maria. Yeah, the report identifies a number of technical kind of process logistics barriers that which Kunal and Jeff have mentioned, economic as well as some kind of regulatory and policy factors that may inhibit recycling. Some of the major, in terms of information gaps and data gaps, we found that there is kind of a lack of publicly available information about the volume, kind of timing and condition of retired batteries. And it's fairly limited and variable, which can create uncertainty and investment risk. So for instance, like the lifespan and average condition of EV batteries when retired, is still fairly largely theoretical, because the first generation batteries for EVs are just now reaching end of life, or their forecasted life expectancy. So varying life expectancy, remaining charge rate, deployment assumptions, among other metrics, really can account for variability in expectancy projections, which can impact insight for certain markets, and the potential for supply of recovered materials. In addition, we've also found that in terms of the regulatory scheme, in the US in particular, is very complex. Used batteries kind of accumulated or stored before recycling, and those being recycled may be regulated as solid waste and potentially hazardous waste in the same manner as those being accumulated or stored as for disposal. So there's not necessarily a regulatory incentive there. And the solid waste laws vary by jurisdiction in the US, and they really mandate very specific handling, storage, treatment, and recycling and disposal requirements that carry civil and criminal penalties for noncompliance. So that's definitely something that we pointed out as that can be a barrier. Also, in terms of logistics, which we've talked about, transporters of EV batteries are also subject to really stringent Department of Transportation hazardous material regulations and export regulations as well.
Wow, that's quite a basket full of stuff that has to be worked out. We'll go on to a second set of questions, unless Jeff or Kunal wanted to weigh in, or any of you wanted to weigh in on what we've chatted about so far, or we'll just keep going if we have no particular comments. So Jeff, we want to go back to you and ask, how do you see the end-of-life electric vehicle battery chemistries and quantities changing over the next 5 to 10 years? And you talked about logistical challenges, and a big cost is the cost of collection, which is the case with most recycling systems, collection and logistics. But how do you foresee logistical challenges managing the batteries? Will the economics look a bit better when you've got a much more scale and much higher numbers? So if you can tackle that big question of the future.
Yeah, it's a beautiful big question. I love it. Look, we have two chemistries today, right? Nickel metal hydride and lithium. And I don't think they're going anywhere this decade, and maybe even the 30s decade. There is so much capital being deployed behind lithium right now, and the companies need to evolve that through innovation and then pay down that capital. And I mean, when I say companies, both the OEMs, but also the recyclers. And I think there's also more innovation to be had in those areas, both on mileage or range, I guess is the word that we use in the industry, but also in years of life. What I think is going to change right now, there's about what you see coming out of market is 80% nickel metal hydride. I think you're going to have that flip, and at the end of the decade, you're going to have 80% lithium. But I don't think the unit volume of nickel metal hydride is going to go down. I think it's just lithium that's going to grow. Nickel metal hydride is a great chemistry and works fantastic in plug-in hybrids. And I think you're still going to see those vehicles on the road. They are an excellent solution for inner city driving. So on the innovation front, the OEMs and the battery manufacturers are going to keep focusing on range and lifespan. As much as warranties are 8 to 10, 12 years right now, we actually don't know how long these batteries are going to last. And I think we're going to see these getting into the low teens, which is one of the goals. My guess is once we get to a certain level of perfection there, we're going to see innovation in the areas of battery design so that they can be more easily repurposed and also more easily recycled. What I mean by that is less waste, easier to process, higher recovery rates, higher recovery dollar value type of thing.
Right.
And I think the second part to your question there, which was challenges of logistics, look, it is cost structure. In North America, we could ship anything anywhere. You could hire someone and they'll deliver something for you. It's about the cost structure. So we'll get to a point where there's enough batteries that full trucks will start moving around. I envision a place where a truck will have a route and it'll pick up different batteries from different car manufacturers and they'll take them to the right place. And through that movement of weight on full trucks, you're going to start to see some costs coming down. That'll be the single biggest help to reducing the freight cost.
Yeah, reaching scale. So Kunal, how do you see markets for repurposing electric vehicle batteries evolving, and how might this impact your company, which only receives material when it's done with the repurposing and definitely at end of life?
Yeah, I think there's a number of groups trying it. There's some one-off projects or there's certain applications outside of automotive, or we always think repurposing from automotive going to energy storage, but I think the reality is the repurposing is going to smaller electronic devices and the like. I think it's very hard, and the challenge that industries or sector is facing is the ability to get certifications and approvals to connect, a secondhand battery into the grid. And also the sourcing of getting consistent material feed of the same type to build a consistent output product. Because if you have hundreds of different types of batteries coming in one or two, you're not going to be able to produce tens of or hundreds of the same product. The other critical factor is the raw materials. So we see a lot of repurposing happening with LFP batteries, but from an OEM perspective, what we see is they're concerned about raw material supply. And when I talk about raw material, nickel, cobalt, lithium. And so they're trying to maintain control over that stream, at least as Jeff was saying, through the warranty and dealerships, so that they can get the materials back and provide another source of nickel and cobalt and a more sustainable source. So there are two competing factors there. I think, as in the last panel said, of course, recyclers going to say recycling is the pathway. And I think the real driver is going to continue to be the commodity and material prices and scarcity of supply of some of these materials that will push people to make the decision towards recycling.
Thank you. And Taylor, in the report you did on the circular economy for EV batteries for the NREL, you looked at secondary uses and second lives for batteries, and what were some of the challenges around reuse and reconditioning and second life uses that you found through that report?
Yeah, the study identified a number of different challenges. So for instance, in terms of technology, there are many different battery chemistries for EVs, and there's no standardized module or cell structure. And having those different shapes, sizes, and material compositions creates challenges in, when you're trying to standardize a process for safety and reliability testing for secondary use. There's also, we didn't find much guidance on trying to make those determinations on, safety and reliability. And I think that really does, impact consumer trust and confidence, as well as there's limited demonstration projects out there, which I think really does impact consumer trust and confidence in kind of secondary use products. Another thing that we actually don't mention in the report, but I think that it does kind of fall in line with how it can impact consumer confidence is how the industry talks about decommissioned batteries. I hear the phrase a lot, end of life, when we're talking about when I'm talking with industry experts in the context of reuse and repurposed batteries. And I think that phrase alone and that terminology can really impact the way that we think about these batteries in terms of safety and reliability. When you look at other reuse markets like the car market, for example, car dealers aren't referring to those used cars as end of life. So I think there's some small kind of terminology changes that we could look towards. And then, of course, on the kind of regulation side of things, in the US, state and local regulations for interconnection and fire and building and electric regulations really vary by local jurisdiction, and they're often unclear on how they apply to battery energy storage. So this can create uncertainty, and the lack of guidance may kind of impact how EV batteries could be used in this kind of secondary stationary battery energy storage market.
And one of the things I've heard from people in the energy storage business is, why would I buy, as the price comes down so much, why would I buy secondhand when I can buy new and totally know what I'm buying?
Yep.
Rob, are you coming back on? Because we're out of time. I didn't know how the schedule has shifted.
Yeah, it has. Yeah, so we're back on the schedule. So
Okay.
Are you good? So I mean, I
Good.
think your panel could have used more time. No question about it. There's so much good stuff going on.
We could be here all day.
Yeah. I like Taylor's point about the end of life thing. Maybe it's like end of first life or
first life. Yeah, we use that a lot. Yeah.
All right. Thanks very much, folks. I'm going to turn it over to panel number 3, which is going to be moderated by Jeff McCarney. And Jeff's got many different hats, so I'll let him introduce himself as well as his panel. Thanks very much.
Yeah, thank you, Rob. And it's a pleasure to be here. I know I missed the earlier parts of the discussion, but from what I caught in the last panel, sounds like a really great discussion and focus so far. We're going to go into panel 3 is looking more at the design and technology issues for optimizing circular economy potential for batteries in passenger and commercial EVs. The focus of this panel is really, whoops, I've lost, somebody just took over my screen here. 1 second. Sorry about that. And we're really going to focus in this panel on key considerations, challenges, and opportunities to enable a closed loop circular economy approach to batteries. This will include both their components and mineral compounds and how they address safety, environmental, and economic objectives. So for myself, I'll be moderating the panel. As Rob mentioned, my name is Jeff McCarney. I'm a professor of environment development at the University of Ottawa, but I'm also the Senior Director of Research for the Smart Prosperity Institute, which is based at the University of Ottawa. We're a national Canadian research network and think tank focused on environment economy issues with an active research line in circular economy, in particular in primary material requirements, metal and mineral requirements for low carbon transition, and how those feed into innovation policy needs for circularity. But I'm pleased to welcome our 3 panelists who we're interested to hear more from in this section. They include first Dan Bowerson, who's Senior Director Energy and Environment at the Alliance for Automotive Innovation. Second, we'll hear from Dr. Shankar Dasgupta, who is the CEO of Electrovaya. I hope I said the company name correctly there. And our third speaker is Jeff Spangenberger, who is the Materials Recycling Group Leader at Argonne National Laboratory. So first, I'd like to ask each of you in that order, Dan, then Dr. Dasgupta, and then Jeff, to maybe quickly introduce yourself and speak to your organization and specifically what you're doing in this space. Keep that to 1 minute, and then we'll move on to a few specific questions. So first, over to you, Dan.
Yeah, thanks, Jeff. And as you mentioned, my name's Dan Bowerson. I'm with the Alliance for Automotive Innovation, or Auto Innovators. We're the trade association for light-duty automotive industry in the U.S. We're focused on creating a safe and transformative path for sustainable industry growth. Our members represent manufacturers producing nearly 99% of cars and light trucks sold in the U.S. We're involved in regulatory and policy matters in the light-duty vehicle market across the country. Membership includes both vehicle manufacturers, suppliers, technology, and other automotive-related companies and trade associations. And In my role as Senior Director for Energy and Environment, I'm directly involved in fuels and vehicle electrification policies and regulations. So this includes anything from fuel quality, clean fuel or low carbon fuel standards, EV charging and hydrogen fueling infrastructure, and pertinent to today's discussion, EV battery life cycle, which includes obviously critical minerals and end of life and everything in between.
Thanks very much. Dr. Dasgupta.
Thanks, Jeff. I'm with Electrovaya. We make lithium-ion batteries. And some years ago, we used to make lithium-ion batteries for Daimler, for one of Daimler's electric cars, which the consumers didn't like that much, so they didn't sell as many. But what we did was merging a lot of the technology we had along with the acquisition we made. We pushed hard on the longevity of the battery, which is very important in this. And so our batteries, typically we think are running equivalency of about 2 million kilometers. And so we've gone into the commercial markets where you really need longevity and which is operating round the clock, 24 hours a day, and electric buses, electric forklifts, and so on. So longevity has been a big driver for us. And the second driver is safety, of course, which is not so much important in this circular economy, but it is, because we notice that if you're making unsafe batteries, the OEMs get scared and brings them all back. So which has happened with a recent OEM or recent multiple OEMs. So we are pushing both these directions and look forward on this discussion today.
Thank you. Yeah, really key point that we can't move forward on circularity if we know other dimensions of sustainability like safety and things like that. Last to Jeff.
Yeah, thanks, Jeff. My name's Jeff Spangenberger. I work at Argonne National Laboratory, as mentioned, where I'm a materials recycling group lead. But I'm also the director of the Recell Center. It's spelled RECELL. It's a U.S. Department of Energy funded battery recycling research center, where our overall goal is to go beyond what technology there is out there today and to improve the economics of these advanced batteries and the recycling of them.
Perfect. Thanks very much. So it really interesting in diverse group backgrounds related to EVs, life cycle, longevity issues, recycling. So I look forward to a good conversation. And just to encourage folks as we move along, I will be looking at the Q&A and the chat. If you want to post questions or ideas as they come up, we'll feed into those later on in the discussion and hopefully have a good time for a rich discussion there. But first, maybe we'll come to you, Dan. From your viewpoint at Alliance for Automotive Innovation, how has the auto sector started to come to terms with the growth of EV battery demand and management challenges in North America? For example, how have approaches changed over the past few years?
Yeah, thanks, Jeff. Great question. So as you know, and you've heard today, and it seems like every other day, there's a new announcement coming from the auto industry on electrification, but we really are in a transformative period. And the industry has committed itself to electrification. So I just provide you with some numbers that maybe help show how we're coming to terms. So the industry will have invested over $330 billion in vehicle electrification by 2025. Within that same time span, EV models are going to grow from 50 available today to over 130. And these vehicles, as you've seen already, will have longer range, more capability, different market segments at a variety of price points. Looking at US specific, in August 2021, sales of zero emission vehicles, which we consider battery electric, plug-in electric, and fuel cell electric, accounted for 4% of the total sales in the US. It's up 2.1% from a year ago, but still a long way to go. President Biden and several manufacturers have set goals of 50% EV sales by 2030. So while, like I said, we've made quite a bit of progress, there's quite a ways to go, and it's going to take collaboration and cooperation across sectors, both public and private. But this obviously also means we're going to see a significant increase in demand for batteries to power these vehicles. We've heard recently from vehicle manufacturers starting to build their own manufacturing plants for batteries, and others who have struck strategic partnerships with manufacturers. So as the battery is the most critical and expensive part of an electric vehicle, it makes sense that the industry is so heavily focused on ensuring that the supply chain can support these increases.
Thanks very much. The future demand that goes along with these trajectories, I think, is really important. I think through the material requirements, how they're going to be sourced, whether it's going to be done vertically or horizontally within industries. I wonder if you can speak a little bit more to some of the challenges you see ahead in moving to a truly closed loop or sustainable EV battery economy to sort of help meet that demand and recycle materials to the system.
Yeah, happy to. So, we push for, we advocate for demand side solutions. So we look at those as necessary, and that's, the charging infrastructure and the vehicle price. They're going to be able to address some short-term challenges, but they're only going to be successful if they are aligned with the supply side realities, right? So we've heard already today, vital aspects of the supply chain when we look at the manufacturing of batteries, which includes critical mineral extraction, processing, production, and then of course end-of-life recycling. So that full kind of circular supply chain as we're talking. And we're currently, North America as a continent, and specifically Canada and US, are lagging in all of these. So we look at this as really one of the best opportunities to develop long-term and sustainable leadership through investments in manufacturing and end-of-life recycling, secondary use opportunities. The short-term investment that we talk about, we think is required for some of the initial startup period. It was encouraging to hear Jeff in the previous panel state that, we have enough capacity right now and enough capital to increase, but, we likely will see some areas where we're going to need some investment, both public and private, to help that. And I know Jeff Spangenberger is going to go into much more detail here, but we really see EV battery recycling as an important opportunity that can help reduce our reliance on foreign nations for critical minerals while providing energy security. This can help by keeping those critical minerals and recycled materials domestic, and then use them to manufacture new batteries. And with that, obviously, the secondary use opportunity it's certainly unique when we talk about EV batteries. Before we get to recycling, there's a great opportunity to use as much of that battery capacity as possible, whether it be stationary storage or support for solar or wind. So I think it's a great opportunity. And like I said, it's one of those areas that we should be mentioning, or we should be trying to take a leadership stance here and getting more manufacturing and recycling domestically.
Thanks. Yeah, really interesting points. I think aligning both the demand and supply sides to improve manufacturing and integration of secondary supply, and also the point about extending battery capacity as much as recycling material through the system, which is probably a really nice transition over to Dr. Dasgupta and what you're doing at Electrovaya. Your company is a leading lithium-ion battery manufacturer, supplying a range of commercial end users. You already mentioned before longevity advantages you've seen, but what kind of design and management issues are you employing to address the potential for meeting circular economy objectives in the markets you're supplying?
The lead acid battery guys, I know it's an old technology, they did a good job in the recycling side. They are recycling over 95% of the things, and lead acid batteries don't last as long as the lithium ion. So our design cycle has been two directions. One is to increase the longevity, and that we are doing really to make our the folks, we are going after the more commercial areas. So we have a exclusivity with the Toyota group, for example, and now you'll see our batteries all over the place, which the Toyota group is selling. And there the push was, can we make a 15-year battery, 17-year battery? And in the electric bus segment, we are seeing demands coming, saying we would like that battery to last 12 years. And from the data we are seeing from our work with Walmart, for example, that it looks like our batteries will do that kind of, and maybe a little bit more than the 12 years, maybe 15, 17 years. So that's one direction. The second direction, which we, and I guess a lot of other battery makers are doing, is to make the in some sort of a sustainable blocks. So if some portion, and these are more like a Lego design, so that if some portion is defective, can we replace it easily? replace a cell, replace a bunch of cells, update the battery management system boards, update the connectors, etc. So that's the second direction going in. And I think, as Dan said, that ultimately you're having urban mining. You know, if you can find the batteries being used, and especially with the high nickel, cobalt, expensive materials, urban mining is much easier than mining from something which is, low tailing. So from the manufacturer's point of view, it's good that this security of supply is a big thing as well. You know, that supply chain, domestic supply chain is very critical for North America. And so I think everybody's moving in the right direction, Jeff.
Thanks very much. It's an interesting point. I know there's been a report from the World Bank recently on how the lead acid batteries have done well on the recycling side, standardization of design and materials, and whereas on the lithium-ion side, there's a lot of innovation in different components and processes, like you're highlighting, that lead to increased durability or improved longevity, modular designs to allow replacement of specific parts instead of replacing the whole battery. What, from your view, needs to be done to help us move further in this direction? Are there policy or other supports that could help you do that better?
I don't know, Jeff, who you are. Just one other quick question I should the lithium batteries are an evolving technology. It has not commoditized like the lead acid. So what you figure out to recycle today would be a different battery, which will come out tomorrow. Like, for example, Electrovaya was one of the pioneers of the lithium iron phosphate battery. We, Hydro-Quebec and University of Texas, put up the first lithium iron phosphate battery many years ago. That technology now, at least in North America, very few people are using it. So we are, as Electrovaya and others too, working very hard on solid state battery. And the solid state battery, again, the components changes. And again, I'm always an optimistic guy. Researchers have to be. We think we'll get our solid state battery commercial pretty quickly. So then again, the challenge is all the effort you put in recycling some other battery changes anyway. So it's a moving target.
Yeah, it's a really good point about the complexity of the challenge when you have an evolving technology in that sort of moving target and increasingly improving performance, and how do you feed that back into a secondary market? It's probably a good point to switch to Jeff Spangenberger then, because I know you think about these things. And so at Argonne National Labs, you mentioned your Resell Center, and your team has been doing a really deep dive into advanced battery recycling. What can you tell us about technological innovations that will likely affect lithium-ion battery recycling industry, and maybe how it can keep pace with these changes that we're hearing about?
Yeah, thanks, Jeff. Yeah, I think I'll answer that fairly broadly in the sense of how resell is shaped. Let's see. First of all, I kind of want to get up on a soapbox a little bit and talk about the fact that, to me, the goal is really economics, really improving the economics of battery recycling. If I put in my neighborhood some scrap metal out at the curb, somebody comes and picks that up within 30 minutes. And that's, it's because there's value there. So if we can make these batteries have value, we can get this perpetual movement of recycling a real thing. So that's why I think economics are so important. Resell, in order to improve the economics, has 4 focus areas. One is direct cathode recycling. I won't get into that right now, but the idea there is to increase the value of the materials coming out of the batteries that are being recycled. We also have a focus area to recover non-cathode materials. There's not a lot of value in the other materials, but we want to make sure that we get as much value as possible from those materials. Our third one is design for sustainability. It used to be design for recycle. It's still along those same lines, but design for sustainability. And there is a huge opportunity for us to change what we're doing now so that we can make the batteries more economical, easier to recycle in the future. And the last one is modeling and analysis, and we use those as tools to help us make decisions in what we do, the projects that we work on, and in general. We have two main models. There's Everbat, which is something that we use. In fact, it's good for design for recycle in the sense that it tells the cost and environmental impacts at the various life cycle stages of a battery, where in design for recycle, if you have to spend an extra $1 on a battery pack up front so that it's easier to recycle, and you can see that downstream it saves $2, the big picture is it actually makes more financial sense to make that change. Design for recycling is really difficult, and that's why I keep bringing that up too. So it's a very important one, but a very difficult one. I also want to mention NREL has a great model called Libra, and that's more focused on the supply chain, material supply chain. I just want to mention that. And so I think that's the overall answer to the question. Well, let me tie one more thing in. The technologies that we're working on, I hope, will become important to not just the projects, the process that we're working on, but to all the recyclers, so that we can all work. You know, I say this a lot. This is a world problem. We really do need to collaborate, as was mentioned earlier, work together to improve where we are today. And we have some really good stuff today. Li-Cycle and the other companies doing the recycling are doing a good job, but we always want to keep pushing ahead.
Really interesting. Thank you. And good examples to think about in terms of improving the economics of battery recycling. Yeah, a follow-up for you is what do you see as the most helpful roles other actors in the battery supply chain could play to, alongside what you're doing, help accelerate a safe and sustainable EV battery economy? Potential for reuse or repurposing of batteries or other things like that.
Yeah. So the process of recycling a battery is really just one step in a bigger process. We have to collect the batteries. In this case, there's a great infrastructure for vehicles, which is where most of the batteries are coming from. And so that's great, but we need to remove the battery from the vehicle. We have to ship that battery somewhere before it can be processed or pre-processed. And transportation, as mentioned, is expensive. And as I mentioned, we have to remove them. There's costs associated with that. So there are a lot of costs beyond just recycling them, and we need to take advantage of that. And second use is something that I think has some real opportunity to extract more value out of a battery before it does hit recycling. Second use right now isn't really a major focus in resell, but I do think that it all needs to work together to make the whole system financially feasible, not feasible, but financially attractive.
Thanks very much. I'll offer any of the panelists who spoke previously, if there's anything you'd like to come back in on before I can pose a question, or give folks in the chat a chance to add anything else they'd like to hear. But anything that's come to mind for you, Dan or Dr. Desgupta, as we've gone through the conversation, you'd like to add in?
I think just maybe adding on, I know Jeff mentioned that, resell isn't necessarily looking at the secondary use market. I think that the secondary use market will play itself out. I think that there's going to be economic opportunities there that the market will figure it out there. So I think the work that's ongoing at resell is important, looking at those kind of design and actual end of life recycling opportunities. But in terms of second use, it's a great opportunity. I think the market will kind of sort that out. So.
Perfect. Thanks very much. Dr. Desgupta, yeah.
One small thing, what Electrovaya, our push was to have a very high longevity battery, which I think the buses and the commercial vehicles are working at. We had done many years ago some repurposing of the batteries with Manitoba Hydro, and that was about 12 years ago. But what we are looking at a model where especially where we can repurpose the battery with a little bit of refurbishment. You know, something's gone wrong and something, improve it a little bit, and to give confidence to the buyers is to lease those batteries as against sell to the battery. So some refurbishment with a lease, it'll be some sort of, you know, monetary instruments we should be able to use as a policy to get that second or a third life for these batteries.
Perfect. Yeah, I think it's a really important point. Anything to add back in, Jeff? Perfect. I see we've got one question that's come in the chat from Shelby Kitt, and you know, I think goes to the heart of what we think about here a lot at Smart Prosperity too, is given the trajectories and the dynamics and the changes in research that you're all highlighting, what do each of you view as some of the most important policies, or what is the role for government in supporting either, you know, improving battery recycling or the types of investments and innovations you're looking at? Whether you're at a national research laboratory like you are, Jeff, or in the auto industry or battery production. Anything come to mind as key barriers that government could help address or policies could help open up space for you?
I have a comment. Oh, go ahead, Dan.
Yeah, sure. I was just going to say, you know, it's we talk about this kind of holistic and transformative moment, right? It's more than just one, in our case, branch of government or policy. But I do think, you know, there's important R&D to be done that Jeff is working on and getting funding through the Department of Energy. And I think it's important, especially at these stages, to continue that work. I think there is opportunity when we look at circular economy to both invest in manufacturing and the end-of-life recycling domestically. It doesn't make sense to recycle here and then ship those materials overseas to be processed and then sold back. So you can't have one without the other if you're really talking to circular economy. So it's not just looking at recycling, but also on the manufacturing and the processing of those minerals and materials that are coming out of recycling.
That's exactly what I was. That's exactly what I was going to say, Dan. You know, we can recycle all day and we have all these great materials that can go back into batteries, but we need to go further in manufacturing in North America so that they don't need to travel around the world just to come back to us. So yeah, you're exactly right.
Anything you want to add in, Dr. Spitzer?
No, I think that no, not really. I mean, I like the repurposing of batteries. I think some of the OEMs are, but let me just add one other example. You know, again, years ago, when there was not that much recycling going on of batteries, there used to be a company in Trail, British Columbia. I don't know if you remember, and who were brave enough to recycle these lithium batteries. And they were getting the batteries from, you know, some mobile phones and this and that. And one day they had a spectacular blaze and the whole place burned down. I think the company used to be called Tosco. So it's recycling is not a, you know, there's some challenges to it, let's say.
Perfect, thanks. We might have time for one more. I think there's two questions that are kind of related here, and they might be oriented first to you, Dr. Desgupta, and then for the other panelists. But so Bill Westcott's mentioning, you know, you raised lead acid battery recycling earlier on. He's curious about whether there's lessons that we can learn regarding negative environmental justice issues. And Alan's fed in asking about safety issues for lithium impediments or barriers for C batteries. So are the safety issues, how are they coming into play, and how, you know, are they currently being well addressed, or are they still an impediment? So sort of linking to these, you know, broader safety, environmental justice aspects. Do they come into your thinking, Dr. Desgupta, and then maybe Dan or Jeff?
No, it's more of a policy discussion. I think the whole infrastructure worked very well for lead acid. You know, lead acid was a reprehensible technology to go into land sites. So there was a lot of environmental pressure to recycle them. And yes, the lithium batteries do have heavy metals, so recycling is important. So I think it's easier to recycle technically once the system is a little bit standardize, the technology. But I think everything is moving in the right direction. And I just want to mention Topscope still is operating. So the name has changed. It's a great company. So,
Dan, anything to add on the safety side?
In recycling.
Oh, sorry. Safety come into play in terms of how you're working with EV battery development, Dan or Jeff, or how you're thinking about it?
Oh yeah. I mean, go ahead, Jeff. You go first this time.
Yeah, safety is always key. Every time you hear about a fire, it gives the whole lithium-ion business a black eye, right? So safety is always number one. We want to make sure that recycling processes are safe, and that's always the number one thing that you have as you plan any process. And handling the batteries themselves can be a problem. I think that's all I had to add.
Perfect. Any last quick comment, Dan? I think we're coming up against time.
Nothing to add on safety, just would say I know equity was brought up there, and that's certainly in all the policies that we're dealing with. Equity and overburdened and underserved communities is constantly a topic and something that we're looking to address. So
perfect. Thanks all. And I'll note Jacqueline Van Tonder from Metal Tech Alley just highlight they are still recycling car and lithium batteries and trail, and put a link there. So I see you pop back on, Rob, so I'll pass it back over to you, but thanks to the panel. So great discussion. Appreciate the contributions.
Thanks, Jeff. Thanks, panelists. That was really great. Interesting to hear about the lead acid battery story as well, because it is a bit of a success story, but I see a question in the Q&A about that as well. So interesting stuff, and should inform our decisions going forward. So I'm going to introduce the fourth panel, and it's about policy approaches and instruments for advancing electric vehicle battery economies. And I will be the moderator for this one. So instead of sitting on the sidelines, so I've got three folks. We got to talk about the Quebec Critical Mineral Strategy, California EPA Lithium-Ion Advisory Committee, and the European Union Battery Directive. So what I'll do is I'll start by introducing myself as I had before. So it's Rob Sinclair, Senior Policy Advisor with Natural Resources Canada, in the lands and minerals sector, in a entity called the Canadian Minerals and Metals Plan Secretariat, which is doing a lot of things to advance the Canadian minerals and mining sector. But one of the things we're also working on, one of our legs, our pillars, is the environment. And within that is the circular economy. And so a couple of things that we're doing is supporting sessions like this to convene and facilitate the discussions regarding recycling, reuse, and that kind of stuff. And the other part of our circular economy world is mining value from waste, which is the reprocessing of mine tailings, which we're not talking about here today. So let me turn it over to my panelists and just get a short introduction from each of them as to who they are and where they work and what they're doing on electric vehicle batteries. And I'll start with Jean-François.
Hello, bonjour. Mon nom est Jean-François Belland. So I'm Vice President of Invest Quebec, the division of Ressources Quebec, essentially the division in charge of energy, mine, hydrogen, and the electrical battery in that case. Background energy, background nuclear energy, and public policy originally.
Okay, fantastic. Carolyn, can you introduce yourself, please?
Hi, good morning or good afternoon to everybody. My name is Caroline Godkin, and I am a Deputy Secretary for Environmental Policy and Emergency Response at the California Environmental Protection Agency. I am a policy advisor on hazardous and solid waste and the circular economy. And relevant to today's discussion, I am leading the lithium-ion car battery advisory group set up within CalEPA that has over 20 stakeholders currently participating, and we are tasked with creating recommendations for as close to 100% of lithium-ion car batteries to be safely reused or recycled at the end of their life. Thanks.
Oh, fantastic. Thanks for that. And finally, Ehud, can you introduce yourself, please, to the audience?
Yes, good day. It's an honor for me to participate from Europe all the way. I'm a policy officer in the European Commission in Brussels. I deal with mostly with the new legislation on that the Commission has proposed to the European Parliament on batteries as part of a small team. we're dealing with all batteries in this. I'm particularly dealing with the aspects related to electric vehicle and energy storage batteries, and looking forward to our discussion.
Okay, great. Thanks for that. Well, this session's going to roll along just sort of in the same way that panel 2 did with Maria Kelleher. So my first question will be to Jean-Francois. So Quebec has made some really strong advances to position the province for entry into the EV market. So for some of our audience who may not be familiar with what Quebec's efforts in this area, can you paint the picture for us? Like, how did you get to this point, and what are the essential parts of the strategy as it sits now?
So essentially, let's summarize the battery strategy of Quebec is based on a triad of industrial policy, energy policy, and public policy, pure public policy. All this supported by strong political leadership plus strong public policy leadership. So we started this initiative 2 years ago based on few key basic factors. First of all, we have the natural resource for the battery, lithium, graphite, nickel. So all this being based, we have what's needed to go inside the battery. Plus, we have clean energy, abundant hydroelectricity, 37,000 more megawatt of electricity with Hydro-Quebec, clean, affordable electricity that will transform these minerals. Plus, in parallel, strong, as I started with, strong public policy. There is a goal, there is an objective. We have a clear mandate at Investment Quebec and Hydro-Quebec to grow on these train and grow the segment from the mineral to the cell. We have a clear mission, a clear goal, and it's clearly focused on this element: CAM, pre-CAM, minerals, critical minerals, including the ownership of some of these assets, Nemaska, Nouveau Monde Graphite, for example. And in parallel, we started to, based on the expertise we already have, we have in Quebec Lithium, for example, on recycling. We have Lyon electrical bus, in parallel on the Nemaska, in parallel of Nouveau Monde Graphite and others. So we have strong already part of the supply chain, and we decided to bridge the gap in some element like the cell, the CAM, pre-CAM, and the chemistry of the battery. And that's where we decided to put all the pieces together, moving along all the departments together under the leadership of Investment Quebec and Ressources Quebec, more particularly, where the expertise is. So that's it. That's actually more than 20 months in the making of this strategy, moving on slowly, but moving on several angles and attracting key players around the world and working closely in parallel with other parts of Canada. It's not a set-alone policy or the willingness to build an industry in the province. We work closely with Ontario. Obviously, we work closely with the federal government, and all this integrated in the North American market. There's absolutely no doubt that we are all integrated in the country and in the North American market. So that's what we're doing right now in Quebec in 4 minutes.
Fantastic. Yeah, sounds like there's a lot of players involved, and again, I think it speaks to that whole thing about collaboration and bringing the right people around the table. So that's great. Caroline, I'll turn to you. California has, as we mentioned, established this lithium-ion advisory group for the car batteries. So to advise the legislature, I believe, on policies pertaining to the recovery and recycling of the batteries. So can you tell us about the journey that your state's taken? What are the key issues, recommendations for the group, and that kind of stuff? Thank you.
Absolutely, thanks, Rob. And just to take a step back and to put into context why now for the committee and the importance of the work we're doing. As many of you probably know, California does have the target to be 100% of new passenger vehicle sales to be zero emission vehicles by 2035. Currently, about 10% of the California new vehicle sales are zero emission vehicles. It is the leading export from California. But we still have a long way to go in looking at this. And as part of that, just recently, we have generational levels of investment in zero emission vehicles as part of a $15 billion package to address the climate crisis. There's close to $4 billion of investments in zero emission vehicles, including around about $1 billion for consumer adoption of zero emission vehicles. And it was great to hear the previous panel also talking about equity and equity consideration. And some of that will include investments to allow lower income Californians to have access to these zero emission vehicles. In addition, in a separate pot of money, we are investing $270 million in revitalizing recycling markets, but also moving California towards a circular economy. So there's a lot of themes that we've discussed today from the other panelists, all coming together in California's investment plan. So there's a slight challenge always of going last in these groups of folks, that all of the issues that have been identified today, both around the logistics, about the management and the economic incentives, really are the opportunities that are facing California. So as in the next 5 to 10 years, as we start to see the large scale vehicle retirements, there is a huge opportunity for either for second life applications, which is kind of how we've been framing after the battery is done in the vehicle, but also, as we've heard, for materials recovery and recycling. And as we think about it, moving to a truly circular economy with these resources, as we see these large scale vehicle retirements. But also there are challenges with the management. Some folks have already identified some of the safety concerns, the logistics concerns, but also the economics of getting the infrastructure up and running. So we are at a moment in California where we have this opportunity to hopefully get things right. And that is the charge of the Lithium-Ion car battery recycling committee. And so again, we have our tasked by the legislature with ensuring that close to 100% as possible of lithium-ion car batteries are either reused or recycled at the end of their life in a safe and cost-effective manner. Our recommendations are due to the California legislature in April of 2022. We've been incredibly fortunate to have a wide range of experts on the panel, and the previous panel talked a lot about collaboration and this really needing to bring all stakeholders to the table. We have participation from the auto manufacturers, from auto dismantlers, from standard experts, from reuse experts, as well as solid waste management agencies who are starting to see some of these batteries show up at the end of their life. We've put in hundreds of hours of work and discussion as we move towards our recommendations, which we will be finalizing in the coming months. And I would say all of our work is public, and anybody is definitely welcome to participate. We've had research support from the University of California at Davis, and we've heard from just a huge range of experts, many of whom are either on the call today or are participating. So looking specifically at our recommendations, and again, we've covered a lot of the issues that we're facing and we're looking at today. So first up is looking at the development of recycling facilities and collection facilities within California, and what role we can play in California government to incentivize that. But again, speaking to a point that was made by the last panel, protecting public health and environment, and making sure that we're not placing additional burdens on historically overburdened communities in California. How do we define a responsible party for the end of life? And including, I think as one of the first panels talked about, the auto dismantlers and who is actually going to be responsible for that battery, and who is responsible for orphan batteries, to making sure that they end up back in the value chain and again, don't show up as solid waste. How do we incentivize quality recycling, battery return, and increase information sharing? So we all understand what is happening with the battery, how the battery has been used, what its composition is. And then finally, how do we facilitate safe and appropriate reuse of batteries? There is a huge potential resource once the battery is out of the vehicle and no longer to be used in a vehicle. But how do we make sure that we don't have an unregulated grey market or improper dismantling? And again, that's all to address safety concerns and public health and the environment for historically overburdened communities. So as I said, we are coming to a public draft, will be available at the end of December, addressing all of these issues. And we definitely encourage everybody to make comments and provide input. And also to, if the broader context of a California zero emission vehicle strategy through the Governor's Office of Business Development is how we're going to actually meet that 2035 goal of 100% of new sales being zero emission vehicles. So that was a bit of a lightning round. Thanks.
That's a lot of information. That's great. I see Marion has put a link in the chat space there as well to what the advisory committee is doing. And I'm just wondering about Jean-Francois and whether there's any parallels or anything that resonates for you in terms of maybe Quebec's already talking with California. I'm wondering about that advisory committee. Is there something like that in Quebec that played a role?
So yeah, clearly, we the reality is we base our action on 3 elements. So first of all, we don't want to reinvent the wheel. Second, we study history. We want to know what happened, for example, in the traditional car market and other, not to duplicate a mistake that we're committed. But also we benchmark what is being done around the leading jurisdiction. And obviously in North America, you have California that is clearly leading the pack, one of the main state or province leading the pack. And we are looking closely what they're doing and sometimes taking their best policy, their best angle to move quickly, because the reality, we are an extremely rapid pace mode in this. It's a sector moving extremely rapidly, the technology is moving rapidly, the capex is moving rapidly and being invest, and we see every day these announcements. The market is moving, and again, as often in the environmental field, California is leading the pack. So yeah, we're following and benchmarking with them.
Okay, fantastic. Well, that whole idea about lessons learned and best practices is a nice segue to our third panelist. So Ewout, I know that the EU has established a comprehensive framework to manage and sustainable approaches to electric vehicle battery management. In fact, I think the battery directive goes way back to the beginning of the 90s. So with the advent of electric vehicles and larger batteries, how was the directive amended? What are its goals? Are there carrots and sticks in terms of how you get it implemented? I wonder if you could give us a bit of an overview. And I think that you have a slide as well, so I'll ask Marion to upload that while you're speaking.
Indeed, but I'll start a bit more broader. And you're right, we had already legislation on batteries, but there was no mention of, for example, lithium in them. So there was really need of an update. And this is the last piece of the puzzle, actually, for the future work on batteries in the EU. It's one of the ingredients. Research and development is one. Right investment support under the right conditions. Also making sure we have the skills for future employees of all these factories, and all that we've set in motion also with the help of the European Battery Alliance. But this is the last piece of the puzzle, legislation. And this comes out of 3 threads of work. One, updating that old batteries directive, which dealt, in fact, only with the end of life part, extended producer responsibility, recycling, collection, and recycling. So, and that all needed an update. As I said, it talked about cadmium and lead only. The second strand of work is really making sure we do these investments right, also in terms of environmental conditions. So that's why we had a work strand on eco design, especially for the big batteries, electric vehicles, and energy storage, to make sure we produce these with the right environmental conditions. And the third thing actually is that we are in the process of creating a new kind of product policy under our so-called Green Deal and our Circular Economy Action Plan. And there we really focus on the entire life cycle. And this slide hopefully will show that. But as I said, and I will not go in all detail because we could talk quite a long. As I said, we've improved the recycling and collection, etc., parts of our legislation that we've already had. But we've gone further also, for example, making sure there's a market to use those recycled materials by proposing that batteries have a certain amount of recycled content of certain minerals in them. That way, we really foster this circular economy. We reduce the need for primary materials. Nevertheless, as you see on the top of the slide, we're also looking at the primary materials. Mining is one of the key aspects. Environmental aspects, also social, in terms of impacts of battery production. So we propose due diligence requirements related to the key minerals that we use in batteries. In addition to minerals, greenhouse gas emissions is an important aspect. We want to save greenhouse gas emissions with batteries, but also they probably should be produced at low greenhouse gas impact. So therefore, we've come up with something that's new in our product policy, a carbon footprint declaration to be followed later by labeling, carbon footprint over the whole life cycle. And this is particularly a new aspect of our product policy. And it goes on. We also have things during the use phase, of course, performance and durability requirements. As I mentioned, it's not only about electric vehicle here, it's also about other batteries. And that actually brings us the challenge. This is a complex area, certainly if we cover the whole range of batteries. And a lot of things we cannot do in all the detail now. We'll have to do them in specific legislation later. But we're discussing the main elements now, the key requirements, and we're hoping to finish this discussion at political level somewhere in 2022, and hoping that sets the right conditions for further investments in batteries. That's what I wanted to share as a start.
Fantastic. Well, I like the schematic. It's very interesting. It shows you how complex it is, and it sparks lots of questions as well. But maybe I'll just ask Carolyn whether any questions came up to you as you're listening to what Uwat was saying, and also maybe the connections between, again, what's happened in Europe and how that's informed some of the decisions being made in California.
Absolutely, and we are definitely informed by our colleagues in the European Union, and I would say that slide that Ewout showed is the perfect summary of all of the different challenges that we're facing, and particularly as we are moving not just in batteries, but ideally a lot of our economy towards a circular economy. And as we are thinking about it, we're thinking about the policies that we need to put in place. For example, a minimum recycled content requirements, but also incentives for keeping facilities within California, but then also the investments, as we're seeing in different parts of the economy. What does the investments look like, and where is it appropriate to place those investments? Again, always keeping in mind protecting public health and the environment and potentially overburdened communities. But we are fortunate in actually we have a member of our committee who actually worked on one of the versions of the European Union battery proposals. So we really are drawing on as much national and international expertise as we can as we do our work.
Oh, fantastic. Jean-Francois, are you still with us? Okay. Yeah, I was just curious. One of the things that Uwat showed in that diagram was legal requirements for reuse. Is that part of the Quebec strategy at all? The kind of the second life batteries?
It is clearly part of what we're reprocessing and recycling at the end, but we're clearly looking at this path also. As we talked previously, we're benchmarking, and then the best practice, that's one of the angle. We have the willingness to limit the environmental impact of the battery in the life cycle. So that's clearly one of the angle we're targeting and moving forward for.
Yeah, my understanding is that the reuse capacity, or the companies that would be active in North America, there's not a lot of them yet. Like, it's still a very we're early days in that area, and perhaps in Europe there's more of that reuse stuff happening already, and so maybe some of that knowledge will come to North America as well. Let me just check the Q&As here. We're getting some questions coming in, I think. And no, that was for previous sessions. So, but I have other questions as well. So Jean-Francois, while we're chatting, I'm wondering about the whole public-private sector collaboration that you employed in Quebec to help build the supply chain going forward. Essentially, how important is collaboration?
But again, it is fundamental. We have no goal of moving public alone without using the private sector. We are moving all together, and we're trying to attract in the gaps we're trying to fulfill. We're working with private company. There is participation of the state, namely Investissement Québec, in sector where to start the will to move forward, we need public investment, public money to support and start the industrial policy process. But it's clearly only to ignite the beginning, and after the private sector is taking the leadership and putting in place the supply chain. So that's the role of the private sector. It's a dual approach, no doubt. Yeah.
Okay, excellent. I mean, in EWIT, in Europe, is that whole public-private sector collaboration consultation thing, does that happen as well when you're out amending the directive? Do you go out to the stakeholders and engage them in the process as well?
Yes, certainly. And not only for this legislation, but I mentioned also for all the other conditions that I mentioned at the beginning, through the so-called, that was done especially through European Battery Alliance. For this, but for this piece of legislation, as for any legislation that we propose, we always do extensive consultations in advance. But I would have to say also during this legal process, because it's such a complex area with so many different technologies. We need to get all the details right, and even after we're done. At political levels, we need to get all the calculation methodologies right, and we rely for many of those also on standardization bodies, on the expertise of industry. So indeed, yes.
Okay, excellent. Well, Caroline, I have another question for you about that advisory group, and just wondering whether it's actually inspiring action at the state level. So do you anticipate progress? What does the near future look like for California? Is it all imminent?
Absolutely. And so we have what felt at the outset in 2021 as a very long timeline is fast coming upon us with the final recommendations due by April of 2022. And those recommendations will be to the California legislature to take action going forward. And there's a huge amount of interest in the work that we're doing, particularly as the adoption of zero emission vehicles really takes off in the state, and we build towards the 2035 goals. And so, as we've seen this year with investments in zero emission vehicles, there will definitely be action coming forth as a result of our work.
Oh, excellent. Very good. I mean, just as another sort of question for Jean-Francois in relation to that, what's the timeline look like in Quebec right now? We may have lost Jean-Francois. I think we did. So that's okay. I think he was getting a call from a politician, I think, while he was on our panel. So Iwit, you have the last word on this. I'm just wondering, you've had a chance to listen to a lot of the speakers and the panelists, other panelists, and sort of the North American focus to a certain degree. And I'm wondering about advice, like from your experience and based on where Europe has gone and what you've learned, what are those, I don't know, one or two, maybe three key lessons that you could share with us?
It's very difficult to translate something from one area to another. In my experience, but it was very interesting to listen. I think so. We're also doing new things on some of these, but where we have a lot of experience is the extended producer responsibility, collection, and recycling. Even though it's not exactly the same in each EU member state, there's a lot of experience built up, and I think that's worth looking into for those places that haven't gone that far yet. For the other parts, testing the whole life cycle, the other parts, I think what we're doing, we have experience for other products, but for batteries is relatively new. So it's difficult to recommend right now to do exactly the same thing.
When you I think I saw you establishing targets for, I'm assuming, collection or capture, recovery. How do you develop those targets? I guess in discussions with industry as to what's feasible, or how do the targets arise?
Yeah, we had already some of those in the past. These are done through modeling. We look at what's possible through modeling. Of course, with experts, but the input of those models will have to come from industry experts, market experts. We estimated what the market is now and also how it will develop. That's how we get to those figures.
Okay, well, that's excellent. Well, we're just about at the end of this, but I'm just looking at the chat and I see a little question here for Caroline, if you don't mind. There was a question about whether California is collaborating with other states or BC outside of your own state.
That's a great question. We certainly have a lot of collaboration, both with other Pacific Northwest entities and our British Columbia in many aspects. Specific to this area, I will have to punt and say I don't know specific to car battery recycling, but we certainly have long-standing working relationships with all of those states and also with British Columbia.
Excellent. Well, thank you. I think we are at the end of our session, and I want to thank all of you, Caroline and Ewout, and also Jean-Francois, who's no longer with us, but certainly did contribute greatly. So I really appreciate your time. Thank you very much, and enjoy the rest of the day. And I think that we are about to do a second poll. So Marion, perhaps you could come on, or maybe Alan as well, just to kind of present that and or launch it, so to speak.
Sure. Oh, Marion can set it up for us, but there you go. This is just a follow-up directly on what do you think governments, and where do you think governments should focus their efforts to support the circular economy for EV batteries? There are a variety of roles that governments can play, and perhaps all of the above might have been a good addition, but we're not going to let you off that easy. So there's 4 choices there. What do you think is priority?
Perfect. So we'll give people 20 seconds to check off the correct box. There's no winning answer. We'll be a little schematic at the end of this to show us which one of those comes out on top. Or maybe like the previous poll, they'll all be neck and neck.
Yeah, all of the above.
I'll give everybody maybe 4 more seconds to submit your answer. Thanks, everyone.
Sorry. Meanwhile, the Miro board has been ongoing. Maybe that's a part of. Maybe Alan, you could, or Marion would suggest. Like, how do we engage with that, or is that something that we'll throw up in the next few minutes?
Well, sure. Yeah, the Miro board is there. It hasn't been used to date, but in past webinars, we found that people do have a variety of thoughts, questions, reflections, resources that they'd like to share after a couple of hours of listening. So I'll get Marion to reload the link there. I think in this case, people have been very actively using the chat, and we have a lot of resources and commentary there, but it's just in the interest of providing more tools for participation, feel free to add your thoughts in as we give a few reflections on the key messages that we've heard over the last couple of hours.
Okay, well, I'll invite Maria and Jeff to put their cameras on and join us as we wrap up this session, which I think we've been pretty good in terms of staying on time. A little bit of a reshuffle there when Jeff Labonte's computer crashed, but I think, and it didn't happen to you, Maria, so you're all set. Everything worked out.
It's a miracle.
Yeah.
Jeff had to step away for another meeting, in fact, a circular economy strategy meeting, so he regrets having to step back and attend another session. So it'll just be the 4 of us, or the 3 of us rather.
Yes. Okay. Well, maybe so the idea was simply to, there was just so much information and so many interesting speakers and a lot of expertise, and it's really hard to pick out the gems, the things that we remember. One of the things that I liked hearing about was the issue of end of life and how that there's just almost a negative connotation with that. And I hadn't actually thought of that before, you know, because who wants to buy something that's reached its end of life? So it's all about semantics, and maybe that's the kind of language we need to change.
Yeah, no, I think that's really fascinating. And I think one of the things that we've heard and is really well reflected by this really amazing group of experts we have here is that these are all interrelated challenges that we have to solve in real time. And semantics is certainly one of them, because consumers need to understand the potential and be brought into you know, a safe way of creatively using all this potential. So I think that is one aspect of it. But I really enjoyed the breadth from the initial vision and getting a sense that there is a vision out there. There's a compelling imperative at an environmental level, but there's also really fascinating economic imperative to get this right. Huge opportunities in the circularity field. However, and the other good news that I brought out of this was the degree of forward momentum. There's lots of solutions out there. There's lots of great tech. There's you know, real passion at a variety of levels to move this forward. So it doesn't feel like we're starting at square one, even though the learning curve is substantial. But one of the key themes is, you know, bringing together, you know, stopping or overcoming the silos so that we can get more alignment, faster learning, and better coordination, so that these different aspects can be brought together in sort of the pre-competitive environment so that we can keep moving. So I took a lot of optimism out of this, and I thank the panelists for doing that, even though this is a big challenge. And but it also says, for me, you know, a primary design imperative for all of our programs going forward needs to be reaching out and sharing the information and working with others to align solutions.
Yeah, exactly. Maria, do you have any thoughts at all as the days unfolding?
Well, I have a bunch of thoughts. I mean, I think the issue is moving at warp speed. And when you're involved in something that's moving very quickly, it's very hard to make policy on the fly. And so that's sort of what's going on, even though everyone's working on it and engaged. So it's fantastic to see all these people working on this, and everyone who works on the issue is very excited about it, including myself. The future is electric, and the batteries are part of that future. But a lithium-ion battery is not a lead acid battery. And so lead acid is a good value. You know, you don't have all these different chemistries. You can recycle absolutely everything. And some of the auto guys are quite shocked that they don't get a big whack of cash for these batteries. They might even have to pay to get them recycled. So it's just a new mindset for the whole supply chain, but local supply chains are the future for everything. It'll take time to build them up, but it's part of circular economy. And Canada is well positioned to be a local supply chain for all the materials needed to make new batteries, and recovering old batteries when they're done is a very important part of that. So to me, the part that struck me today is the role of reconditioning and reuse of batteries after their first life, which we talk about end of first life, even with electronics, because a lot of them have a second life, and so do batteries. So there was just so much to take in. It was great information. But to me, the reuse reconditioning question it got lots of challenges and potential, and is new and needs to be sorted out. So.
Wow. Yeah, no, that's good. The thing I like the references to slabs, right, which came up with the Professor Gupta as well, which is spent lead acid batteries. I mean, we're not starting from ground zero in terms of the logistics of collection, recovery, recycling. And it was mentioned already, and as I think a lot of us already know, the circular economy for lead acid batteries, it's almost the most recycled, you know, closed loop consumer product in the world. I mean, it's between 95 and 100%, because the equipment manufacturers want that lead back. They want that stuff back. And so I believe they more or less maintain possession of that battery as it works its way through the supply chain. And that may be, and again, this was raised as well, whether it's EPR versus this kind of service ownership thing. I can foresee, because of the projected shortage in supply, but the projections in demand that are much higher, that all those folks making batteries, you know, the Panasonics and all those folks, they're going to want to keep them. They're going to want those batteries back eventually. So it wouldn't surprise me if that kind of system plays out, and that will be a true circular economy system, because they will, knowing they want to get them back, will want to get them back. They will design them appropriately as well, so that when they do arrive back in the plant, they'll be able to, you know, recycle them essentially. So
just one of the challenges, and I think we're out of time, is that there's all the different chemistries. Every auto manufacturer wants a different battery design, pouch, or all the other ones, and a different chemistry. So they're not like lead acid batteries, because lead acid batteries are all exactly the same, whereas lithium batteries are all different, slightly different designs, you know, confidential IP on what the exact design. We know it has lithium, cobalt, maybe cobalt, nickel, manganese, a bunch of other stuff, but it's a cake recipe. It's all different percentages. So it's just way more complicated, not unsolvable, but just way more complicated.
So you think those different chemistries will likely stay with us in the electric?
Oh yeah, because they all have a different one that they love, you know. So each automaker will have a recipe, like your grandmother's cake. Each of your aunts had a slightly different recipe to make their cakes taste better, you know. That's the way it works with the whole lithium-ion battery business.
Yeah, but again, I think if the manufacturer maintains some sort of ownership of that battery, they'll get that recipe and that cake, that battery, it will come back to them again. So
but it'll come back 10 years later when they'll have a new design.
Oh,
so,
yes,
yeah.
sure.
No,
Right.
These are all the issues they're trying to grapple with, I think, in California, when I sat in on a few of their meetings. All great questions. Yeah.
Okay, well, I think we probably need to wrap this up. We've got a bunch of things that Smart Prosperity was sharing with us. Now, I want to thank Smart Prosperity Institute for doing all the background stuff on the show and the logistics and all that kind of stuff. I don't know, Marion, if you're going to share these things. Yep, okay, they're going in the chat space right now. There's a follow-up survey. There's a recent report that's come out of SBI as well about primary materials and the emerging circular economy. And there's another event coming up that was already highlighted. A week from today, we're going to be doing end-of-life electronics and the recovery of critical minerals. That may be, some of you will attend that, or it might be a different audience. We're not sure, but the common theme will be circular economy again. And as mentioned previously, this event has been recorded and will be posted on YouTube as well. So I think we'll end that by thanking, again, all the participants for signing in and registering, listening to us. A big thanks to all the panelists for taking time out of their busy schedules. Also thanks to my moderators for doing a great role in running their panels. Fantastic. And thanks everybody, and enjoy the rest of the week. Thank you.
Thank you.